everyone, welcome to day 2 of our DP700 journey with Microsoft Fabric. Today we are breaking down why domains matter, how to organize Fabric efficiently and how Lakehouse integrates seamlessly. Plus, our expert mentor will unpack complex semantic models to help you master Fabric's full potential. So get ready to explore Fabric like never before. Let's dive in.
Let me quickly demonstrate to you how we did Lakehouse development in the Fabric and what all operations we as data engineers do inside the Fabric. We need to onboard ourselves on fabric.microsoft.com with a corporate account and enable the trial. So I have enabled the trial. Let me create a new workspace. So I'm going to go and say create a new workspace, give it a name, Fabric workspace class 02, and make sure that the workspace is created either with a trial fabric capacity or with a premium capacity or with a fabric capacity. Premium capacity and fabric capacity are paid options. We're going to discuss them in the last module, administer fabric. So we will keep our workspace under the trial, and we do not need to worry about large semantic model. This setting is required in case your semantic models will grow beyond 10 gigabytes in size. At the moment we don't need to worry on this front, so I can simply say apply. So here is my Fabric workspace, right? So here we go. Let it load my beautiful Fabric workspace. Wonderful. Right? We will discuss what these task flows are a little later, right? So here we have our empty workspace, Fabric workspace class 02, right? Now we can go to the workloads, and since this is a data engineering workload, I can go inside the data engineering workload, and I have Lakehouse as an option to create Lakehouse object, right? So I can click on these three dots and say I want to create objects. I want to create an object, and the object that I want to create is a lake house, right? Alternatively, you can go to your workspace and you can also create a new item from here itself, right? So I can say I want to create a new item. This wizard that you see helps you to create the item aligned with the task that you want to do. That's called as a task oriented item creation. What task you're doing, which item do you need? So get data task, store data task, prepare data task, right? Analyze and train, and you can see so on and so forth. Various tasks are provided and the items under them are provided to you. When we organize them appropriately, that's what's called as a task flow. We will learn task flows later, right? It's an organization way. Better manage your work, right? So I can create an item. So you can create the item by clicking here, or you can create it from here. Depends on you, right? It's your choice. How do you want to do it? So I'm going to say I want a new item, and the item is for storing the data, and that is a lake house. So let's click on lake house. I'm just repeating what we have learned very quickly. So I'm going to give it a name, lake house LKH01, lake house 01, and lake house schemas should be selected. Create. So here is a beautiful lake house. There will be three objects that will be created when you create a brand new lake house. So if you look at your workspace, please observe that there are three type of objects which are created when you create a single lake house item. So when we create a single lake house item, this is a lake house item. When we create the lake house item, three objects are created: the lake house itself, the semantic model, tabular semantic model, the default tabular semantic model, right? And the SQL Analytics Endpoint. All your Delta tables will be reachable for read only, not for transactions, read only from this SQL Analytics Endpoint, right? So there are three objects that are created when you create a single item. So let's go inside the lake house. Here we are inside the lake house. We see that we have two different views over here on the top: lake house exploration and lake house SQL Analytics Endpoint. Two different options are there. You can see that. One is to explore the data files and folders, and another one is to query it using structured query language, the most popular language for data engineering. So, from here, you can explore your lake house. And then if we switch over here, we will be able to do all the reporting, querying, visualization, consume the semantic model and all of that. We'll come to that later. Let's go back to the lake house. So here we are in the lake house exploration. So what do? We need to ingest the data under the files. You can ingest it in any forms and shape: CSV, TSV, whatever comes to your mind, you can ingest. There are various ways to ingest. You see, these are all the different ways of ingestion. And that's what we will learn all throughout our learning. So how to do a pipeline, how to do a data flow gen 2, how to do shortcuts, how to do event streams. We will be learning how to design all of these beautiful items. But at the moment, we want to keep it simple. So I will be uploading a file manually for demonstrative needs. So I'm going to say, give me a new subfolder data under the files. And once the data folder is created, by the way, all of these are under one lake. I don't need to re-emphasize that. If you just right click and check properties, you will find everything is sitting in the one lake. Right here you see one lake.dfs.fabric.microsoft.com fabric workspace class 02 and all that. Here you can even see the Azure Blob file system over SSL driver URL. This is called as ABFS path. Azure Blob file system over SSL path, right? These are technical URLs. You need not worry what they are, but you can clearly observe that they are all sitting in the one lake. Okay, so here we are having our data. This is also sitting in one lake. Obviously, if you check its property, you'll always find everything sitting in one lake. Wonderful, right? Now, data. So this is the folder, and let me now quickly upload the file, right? So I'm going to say, oops, what happened? Upload. Why is it not allowing me? Yeah, upload the files, select, show all files. I'm going to go to the documents. I'm going to go to the Lakehouse folder, Lakehouse data, and select the sales. Manually uploading a single CSV file for demonstrative purposes. Later, we're going to write pipelines, which you will do in your job when you will be in projects, right? You will be writing pipelines. You will be automating the process of ingestion. So here we have the CSV file uploaded. I want to query the CSV file using structured query language. So if you want to query this CSV file using structured query language, simply click on that file and say, I want to load it to a delta table. There's a small little triangle that you see. This signifies that you are loading it to a delta Parquet format. You are loading it into a delta table, right? So I say, yes, I want to load it into a delta table. Schema DBO, name of the table sales. This file has headers in it, so I'm saying use headers for column names. The field separator is a comma. So I say, please load this in the delta format. And this will create a real table, not a data virtualization table. It will not be a table that we create in Synapse. Remember, in Synapse serverless SQL, we create external tables. Yesterday also we demonstrated that. In Synapse, if you want to query your CSV files using structured query language using open row set function, you're going to need to create, you will need to create that thing, right? You will need to create that thing, which is essentially the external tables. But here, these are not external tables, these are real delta tables, right? So if you were to click on over here on view files, you will see that here is the Parquet file that is available for this There is no option to rename it. Okay. So here you can see that we have the Parquet file that is available over here, right? Whenever you're going to make update into this table, a new Parquet file will be created, as we know, right? Delta tables, we will study delta tables today in more detail. But here we can see the Parquet file with a snappy compression, and here is the delta log in JSON format. This will maintain the changes that you make to the data, the changes that you make, the transactions that you do on this table, right? We'll come to that in more detail, right? What that is. But here is the table. We loaded this into the Lakehouse as a delta table. And obviously, if I view the files, here are the files. If I were to check where these files are, obviously I will find them in one lake. You see that they are sitting in the one lake. Okay, this is the full URL and this is the full ABFS driver path for big data analytics. So it's sitting over there in one lake. Wonderful, right? How do we prove that they are essentially real tables? You can go to your workspace. You can go to your workspace and you can essentially go to your SQL Analytics Endpoints settings. Here is our SQL Analytics Endpoint, and we can go to its setting. And in the settings of the SQL Analytics Endpoint, we find the connection string of the SQL Analytics Endpoint. This connection string we can use in order to connect it to SQL Server Management Studio, Azure Data Studio, or even in Power BI. I had demonstrated all the three tools. You can use this connection string to connect to SQL Server Management Studio. You can use this connection string to connect to Azure Data Studio. You can use this connection string to connect to Power BI Desktop. Please review the recording in case you need to look at it again. We had seen it. And when we look at SSMS, SQL Server Management Studio, our delta table appears under tables, not under external tables, right? When we opened SSMS and we connected in SSMS using this connection string, we found that our table was under tables, not external table. It is a real table, it's not an external table. But this endpoint is read only. This endpoint is not writable. This endpoint will not take transactions. You cannot insert, you cannot update, you cannot delete from your delta table using this endpoint. You cannot use this endpoint for any transactions on your delta table. It is a read only. It is only for query. It is only for tabular data stream session. It is only for queries, select operation. It is not for inserts, updates, or deletes. And there is a very solid practical reason why Microsoft is not allowing you to use this connection string and do transactions, because then those inserts, updates, and deletes cannot be written to the delta log, because who can write into the delta log is the Spark engine, not the SQL engine, right? So they want you that if you want to do the transactions on the delta table of yours, use the Spark cluster, not the SQL engine. And that's what we will study today. So this endpoint which you see at the moment, or the SQL connection string of your SQL Analytics endpoint, is read only. All the delta tables are visible through this connection string. You can use it in SQL Server Management Studio, Data Studio, and Power BI Desktop. Most popular is Data Studio. You see they are giving the option directly over here that you can open it in Azure Data Studio, you can open it in Excel, right? So many options are provided over here, but see explicitly there is an option that would you like to open this in Data Studio. Why? Because that's the most popular option in practical world. We as data engineers love Azure Data Studio because it allows us to do peer programming. It allows us to do collaboration. I can open a notebook, write few lines of code, write some markdown, save it, give it to my colleague. He writes some code, saves it, gives it back to me. I write some more, and the work gets completed. So that is what is happening in Data Studio, right? So you can write SQL reports in Data Studio along with your peer programmers, peer SQL developers. That's why you see that option is coming over here. But the SQL Analytics endpoint is read only. There is one more setting which today some people were interested. Default Power BI semantic model. You know that a default semantic tabular semantic model is also created when we create a lakehouse. This will automatically contain all the tables and the views, all the delta tables and the views that you have in your lakehouse for reporting needs. You can turn it on or turn it off from here. Right now it is turned off, which means the delta tables and the views that we create will not be added to this default semantic model automatically. You will have to synchronize it. We are coming to that. We'll show you very shortly. If you turn it on, that makes your life easy. All the delta tables and all the views will now automatically be added to the default semantic model. So you can see synchronize the default Power BI semantic model, add objects from the SQL Analytics endpoint, that is your delta tables and the views, to the default Power BI semantic model. Also, update the model with any new objects added to the SQL Analytics endpoint. That is, if you create any new delta table, any new view on your delta table, it will automatically be added to the default Power BI semantic model. Now, this will obviously help you to build the reports faster. You do not need to build a new semantic model as a data analyst. Okay. I can keep it on, you can keep it off also. Default is that it is off. You have to synchronize the default semantic model from the reporting view, right? Let me keep it to the default configuration off, right? So please remember this connection string and this default Power BI semantic model. What is endorsement? We will come to it a little later, right? At the moment, we are not at the right juncture to highlight what is certification and endorsement of the material for the enterprise. Can we remove objects from the default semantic model? Yes, you can. In the sense, the default semantic model contains some performance tables also. You cannot remove those performance tables. You cannot remove the performance tables, but you can remove your own delta and your views from the default semantic model, right? You can add, you can remove, that's allowed. Okay. So kindly remember this. This two settings are very important, SQL endpoint and the default Power BI semantic model. So let's go back to the lakehouse now. Here we are in the lakehouse. So we have the files in the CSV. I just created a delta table on top of it, right? And then here is our delta table, which we can clearly observe is over here, right? You can rename the table if you wish. You can check its files. You can check its properties, which are here. You can see it is a managed table. And this is a URL. It is sitting inside the one lake. There are some maintenance options like optimize, V-order optimization, vacuum command, right? We're going to look at all of them. Why do we need them today? But once you have your delta table created, what do you want to do with it? What do you want to do with your delta tables? You would like to find KPIs from them, key performance indicators from them. You might write, you might like to run SQL queries on it because SQL is the most popular language to query structured data. So if you are a data professional, structured query language is a prerequisite. We need to know the SQL. I will be sharing you a full hands-on 4 hours course created by Microsoft free of cost. I will be sharing you that course in case you need any primer. If you want to brush up your structured query language, you can brush it up with that course. I will be available to assist you in case you want to take any assistance. But yes, in case you are not in touch with SQL, I will be providing you a 4 hour course which will help you to quickly cover the grounds on the structured query language. So how to do the structured query language? How do you go ahead and you query this delta table with the structured query language? You guessed it right. We have to switch to the SQL Analytics endpoint, right? So I say, hey, I want to query this with the structured query language. And here you see It's loading the SQL Analytics endpoint. The SQL Analytics endpoint has a default Power BI semantic model to automatically add objects into it. Go to the setting I just told you. At the moment it is off, you can turn it on. To manually add objects, use manage default semantic model, right? So over there, you have that option, right? If I were to now go ahead, what I would do, I would say I want to run some reports on that simple table, which is my sales table. So my sales table is over here under DBO, and here is my table, sales delta table. I can query it. I cannot insert into it. I cannot delete. I cannot update anything because you know that the endpoint is just read only. This guy is read only, right? So I can say I want to do a new SQL query on that. Okay. And give me the top 100 records out of that table. So it will now query. I am running on free capacity, right? Free trial capacity. So it can take some more time, but in a real world, it will be blazingly fast because you would be running around F64 capacity or F32 capacity. Your company would be using a very high capacity, right? So here we go. Let me now run a very simple query, right? So let me first of all rename what I want to do. So what I want to do is monthly sales. On this delta table, I want to compute the monthly sales. So how? Using structured query language. I want to use the most popular language which all data professionals know. So I want to query this delta table with a structured query language. So I simply say select month of the order date as the month, comma, count the number of sales orders. So count the sales order number, which is a unique number for every sales order, as total orders, total orders from this very table, DBO dot sales, database owner dot sales, enter. I will have to group by the month, order date, and optionally I can order by the month so that it gives me January, February, and so on and so forth. So I can order it by the month. Simple report, the monthly sales report. Monthly sales report. Here it is. I can now say to all the business intelligence consumers that I have written a report on the delta table sales. You do not need to run this report. You can directly consume the view on it. And you know what is a view? View updates automatically whenever the underlying data in the sales table will update. How will it update? Through Spark. We cannot update it here. I cannot insert anything from here. So if the data under the sales table gets updated using the Spark engine, okay, the view will automatically update. So I can say that I want this to first of all become an exploration. Everyone in my company can come and look at this exploration, which I just did. So I can simply click here, right? You see this option is here, visualize result. I can say visualize the result of this statement, continue. Super simplistic. So I can create an exploration for anyone in my team to do this exploration, right? Monthly sales. So here it is. So I can draw a line chart with month on the x-axis and the total orders on the y-axis. So it would look something like this, but I would need to remove the aggregation from month. Uh, so it is automatically getting aggregated. Okay, that option is not coming here. I will need to do it from here. So I select it again and then click on over here. Explore monthly sales. Got it? Okay. So select the month and the total orders in the report. Select the visualization to be the line chart. And you would require to remove the aggregation of the sum. So summarization, no summarization. Looks like it's slightly different. Why is it aggregating that? Sum of month, no. Summarization, no summarization. That option is not coming. What happened here? Aggregating the month. It's a numerical column, so obviously you know that Power BI will automatically give me default measures, right? Automatic measure. But what I want is that I don't want it to be aggregated. So why is it summarizing it? Yeah, now it's coming. Don't know why it was not coming earlier. Don't summarize for me, please. And the line chart. Why? What happened? Oh, sorry. You cannot use order by without top n, right? So I will have to use only group by. Ordering we can do in the visualization itself, right? So now we can visualize. I can create this exploration, right? Yeah, we can do that in the semantic model. We can remove the visualization, we can remove that. So month and all of this, I need to remove its aggregation. Don't summarize for me. Now month, and here it's the beautiful chart. The beautiful chart for me, a simple exploration of my SQL query. So I can say, hey, I want to save it as an exploration. Save this as an exploration. Monthly sales exploration of the Lakehouse 1, or I can simply say monthly sales exploration, saving it to Fabric class. So anyone who is a business user can directly look at this exploration. He will not run the SQL query. He not going to go to the Delta table and run the SQL query. He or she is a business user. She does not understand what is a Delta table. She can come and open just this single visualization, which is called as exploration. Save the exploration. I can even save it as a report if I wish, right? But I'm not going to do that because we're going to build the reports through the semantic model, right? We're going to build reports through semantic model. This is just a simple exploration item which I created using my SQL query. I can save this as a view. I can save this as a view for others to consume directly the view, right? So I can say this is the monthly sales view. What is the advantage? If the underlying data of the sales table goes any change, updated or inserted, okay, from the Spark engine, then the view will automatically change, right? That's the purpose of a view. So monthly sales view, and this object also gets created over here under my lake house. Here I can see that my view is also created. So if I want to develop explorations, I want to develop reports, I want to develop views on the underlying delta tables, I can do it from the SQL Analytics endpoint. Okay. So here you can see that I ran the SQL query on the delta table, converted it into a view. So now people can directly run the view. That's it. There is no need for anything else. We can directly run the view only. I can just execute the view. There is no need for me to run the query on the delta table anymore. I can just run it on the view. The advantage is that if the underlying table changes because of inserts and updates and deletes from the Spark engine, my view will also give me the different output. It will automatically update. Okay. So we can create SQL queries, we can create explorations. So you see, here is our exploration. Here is our exploration, which I created. Business consumers can simply use explorations. There is no need for them to go to the SQL Analytics endpoint and then essentially do all of these queries and then visualize. Someone has already done for them. Business users will consume it rather than essentially do it on their own. Okay, do it on their own. They will consume it directly. So save it as a view, our SQL query, right? And then we can run the query on the views. Now, if you observe, the delta tables and the views can be automatically added to the default semantic model. Let us open the default semantic model. What is inside the default semantic model at the moment? Semantic model is for report development. But what is there in this default semantic model at the moment? So I can go back to the lake house and I can go to the SQL query, right? So go to the SQL Analytics endpoint, and you can see here is the option reporting. I can develop a new report. I can develop a new semantic model altogether, but I want to at the moment look at default semantic model. What is inside the default semantic model at the moment? Yes, if you create multiple lake houses, will they be saved under the same one lake namespace? Absolutely. A one lake is for the entire organization. All the workspaces of that organization are in the one lake. right? So one lake is like a country, right? All homes of the citizens of that country are within the country. So imagine one lake as the country. One lake, imagine one lake as United States. One lake is United States. If you are a US citizen, you will have a home in United States, right? So that is the workspace inside United States. And within the workspace, you have different items, right? So all the workspaces are created inside the one lake namespace of that organization, of that company. So all our lake houses and their items, everything, our workspaces, the items in the workspace, lake house is just one item inside a workspace. I hope it's clear. Lakehouse is just one item inside the workspace. You can create thousands of lake houses in your workspace. You can create thousands of workspaces in your Fabric tenant. Your Fabric tenant will use a single one lake, right? That's the whole idea. So here is our SQL query that we run, and we can save it as a view. Now I want to look at default semantic model. Let me click on manage default semantic model. Now from here, I can let them know what tables do I want to add into the default semantic model. What do I want to put inside the default semantic model right now? Because the original setting is off, you can see that originally the default semantic model is not synchronizing. It's not synchronizing with my tables and with my views. Nothing is inside the default semantic model at the moment. It's empty because I am keeping it off, synchronization off. I am not synchronizing at all. So I have two options. I can go to the Lakehouse, back to the SQL Analytics endpoint of the Lakehouse, and go to the reporting and let them know what tables and what views do I want to put in my default semantic model. Or if I automatically update it, all of them will be added. So if I automatically update this sales and this will be added. So automatically update default semantic model. See, all of them are getting added to my default semantic model. But you would like to add some of them and don't add others in the even in the default semantic model. Or altogether you could build a new semantic model. We will look at development of semantic models a little later, but we are highlighting because the original setting is kept off. It's not synchronizing at all, right? So whatever the delta tables you create, whatever the views on your delta table you create, they are not getting synchronized in the default semantic model because we have kept it off. So then how do you put them inside the default semantic model? You go to your SQL Analytics endpoint of your Lakehouse, and when you go to the reporting option, you find over there automatically update the semantic model, which means all of the tables and the views, if they are not in the default semantic model, they will be put inside that. Better option, practical option would be you yourself decide what tables you want. At the moment, these tables are automatically added, right? Because I hit this button. So you have the option. What do you want to put inside your default semantic model? If you hit this button, everything will be added. If you hit this button, then you will have an option. What tables do you wish to add? I can remove this one from the default semantic model. Okay. Or you can altogether build a new semantic model, which we will see later, not at the moment, because we are not looking into hardcore reporting at the moment. But please remember all these options. Please remember this setting. This is very important setting, that whether you would like to synchronize or not automatically. Okay. Default is off. You can turn it on. Okay. If you wish. Default is off. And the second is that on your SQL Analytics endpoint of the Lakehouse, under the reporting, you find the two options to beautifully manage what goes inside your default semantic model, right? What goes in your default semantic model. So if you were to do a new report, obviously the report will be built on the default semantic model, right? You see, both of those tables are popping up because they are inside the default semantic model. We are developing this report on the default semantic model, not on a new semantic model. on the default semantic model, right? So I can do again maybe just a simple visualization for you, which is a line visualization. And I could say that I want to analyze month with respect to the total orders. And I don't want month to be summarized. So that option should be in Power BI, we get it on the top ribbon, but here as a data analyst, I need to find where that option should be. It's already building it, although it is giving, it's not doing the summarization. I'm sorry. Okay, it's not doing summarization. Here it is saying that I'm going to do summarization for it, but when we put it in the report x-axis in the visualization, it's not doing the summarization. Here is a beautiful report that you can clearly observe, right? We can do new measures if we wish. Is there option coming? No, that you have to do in the new semantic model. That option is not coming here. Okay. So here you can see that. So we can develop the report, we can save the report. I'm not going to save the report because that's not our focus at the moment. I just showed you that from the Lakehouse SQL Analytics Endpoint, we can even develop all of these things. A new semantic model, manage the default semantic model, automatically update the default semantic model, and altogether a new report. Now, some of you might have a question in mind. This is a structured query language, which you just demonstrated. I am a data analyst. I am a PL300. I attended PL300. In PL300, we used something called as the Power Query, right? For transformations. Can you do the same thing which you did here, exactly the same thing which you have done here, using Power Query, right? Can we do the same thing using the Power Query? The answer is yes. Why not? We can do the same thing using the Power Query also. But how? Very simple. How do you do that? You say, I want to do a new visual query. Look at this. Beautiful. I want to do a new visual query, right? So I say, I want to do a new visual query because I want, this is structured query language. I want to do it using Power Query. Okay. I want to do it using Power Query. So let's drag this table, select and drag this table over here. This table is now added as the source in the Power Query canvas. See, it is added as the source in the Power Query canvas. And what can I do now? What can I do now with this? What will I do? To do my report, I just need the sales order number and I need the order date. So I will choose the column. So now you see you have the options, your Power Query transformation options, manage columns, choose column, go to column, remove columns, remove other columns, reduce the rows, keep top rows, keep bottom rows, keep range of rows, keep duplicates, keep errors. Anyone who is familiar with Power BI, Power Query Editor, Power Query Online, you know what all this is. These are your Power Query mashup transformations, right? So here we can see sorting transformations, other transformations, which is most popular being group by, aggregation, okay? Combining the two different queries, merge queries and append queries, saving the output as a view and view the native SQL of this entire transformation flow. So what I want to do is what I did here with structured query language, exactly that do for me using Power Query. Okay. So if you are a data engineer, you will prefer this. But if you are a data analyst, you will typically prefer this. You will do a visual query, right? If you are a data analyst. So you're going to say, I want to choose the columns. What columns do you wish to choose? Sales order number and order date. Okay. So it selects the two columns for you, you see, right? Here you have, if you want to remove this step, you can essentially delete this step if you wish. Okay. So choose the two columns. I need the month part of this. So I will select this column and then add and say the next transformation that I wish to do is that I want the month of this date, month of the date. And now I can do the aggregation. I can say I want to develop a report where I want to do a group by the month and the new column that I want is total orders in that month. Count the total number of rows within that group, right? So it will give me the monthly report. And here it goes, month and the total orders. And the last but not the least, I can sort it in the ascending, okay, on the basis of month rather. I sorted on the basis of total orders. So we can remove this, delete, select the month and sort it on the basis of sort sort ascending, right? Sort, delete, select, sort, ascending. Done. Report is ready. Exactly what I did here. If I am a data engineer, I would do this. I would not bother with writing a Power Query, a visual query. But some of you might be thinking, hey, I am a data analyst. I would love to do few things with Power Query transformations. They are very powerful, right? Obviously, they have limitations. It would be better to do advanced transformations using Spark rather than using Power Query, but at least there should be the possibility for me to do transformations and reporting using Power Query. And here you see we have the same visual query. So I can say essentially that this is the same monthly sales, but I did it using what? I did this using Visual Power Query. So this is nothing but Power Query Editor. I did it using Power Query Editor. Power Query has limitations. You know that if we want to do advanced transformations on a large volume of data, we need to push transformations upstream into a Spark engine. Power Query is not made to do transformations on terabytes and petabyte scale data that we do in Spark engine. Right now our file is just few megabytes, so we are doing it in this way. Our delta table contains just few megabytes of data, so we are doing it using Visual Query, Power Query, mashup transformations. But imagine if we had hundreds of Parquet files under our sales table, and then each file is, let us say, of some 500 megabytes, then it would be better to do the transformation in the Spark engine itself rather than here, right? That is called as pushing the transformation upstream, right? No, it does not record the M query. No. So here you can see. So monthly sales Power Query rename, and here it is ready. Now I can save the output to the view. So same thing which we have the option here, save it to the view. You can do the same thing over here, save it as a view, dbo dot monthly sales. So if you want to do it this way, you have the option monthly sales view, Power Query. Okay. Here is a SQL statement, which you can see, right? And say, okay, you can put it in the view, just like the way you did here. Okay. So if you want this experience, Fabric is offering it, right? You don't need to open your Power Query editor in the Power BI desktop. You don't need to do Power Query online. You can directly do inside Fabric, and that is what something which is extremely powerful, because not only data engineers, not only data analysts, all of the data professionals can work together inside Fabric. Fabric brings a unified experience. Everyone can do whatever they want inside Fabric. There is no need for different tools to be used by different job roles like data analyst or data engineers or machine learning. Everyone can do whatever they want inside here itself. Okay. So here you can see I did it using the view. Okay. How do we organize the Fabric? That is the domain of Fabric administration. Please understand, if I take you to the home page, let me take you to the home page. And let me click on the top over here where it says administration portal of the Fabric. Can you see? There is an option which says administration portal. If you are the Fabric admin, if you are the M365 admin, Or if you are a capacity admin, right? Then you're going to have the access to the admin portal. I am not the administrator. Microsoft has not given me admin permissions. If you go to the
Okay.
Fabric admin portal, you will find an option over there which is called as domains. Domains in Fabric I am not an admin. Microsoft has not made me an admin, right? So that's why you see I don't get that option. I have no such option of creating something called as a domain. Okay. So that is not there. So if you see, if you click domain in Fabric admin portal, you see find Fabric domains. It is a domain. Domain are a way for big organizations to manage department wise Fabric workspaces. So if you are the Fabric admin, if you are the M365 admin, then you will get this option in the admin portal. See, I'm not getting it because I'm not really the Fabric admin. Microsoft cannot make me a Fabric admin, right? So they have made me a contributor rather than the Fabric admin. If you are the Fabric admin, please contact the Fabric admin in your organization. They have the option to go to the admin portal, go to the domains and create domains over there. And what is a domain? Domain is a way for us to structure the data in the domain. So I can create a domain for finance, I can create a domain for health, I can create a domain for education, I can create a domain for sales, I can create a domain for marketing. All the semantic models, all the lake houses, all the warehouses, all the workspaces, to be more precise, Fabric workspaces will be organized under the domains. This is how big organizations manage their analytics. They cannot stuff everything in one place. They will have to create folders, right? They're going to have to create compartments. Otherwise, it's going to become a spaghetti bowl. It's going to become a salad, right? They want to keep it nice. They want to keep it organized. So the answer to your question pertains to Fabric administration. You contact the Fabric administrator in your organization and ask them that please create Fabric domains for us: sales domain, marketing domain, finance domain, health domain, education domain. And then once the domain is created, what can we do from our side? When you want to do a new workspace, let's say you want to do a workspace for sales analytics of some client of yours. Let's say the client is XYZ client, some client of yours
Yeah.
for whom you are doing the
Yeah.
project. You will have to put it under the sales domain.
Okay.
Current no domains were created because Microsoft has
Yeah.
not made me the Fabric admin. Otherwise, I would have
Yeah.
created a domain for you. So that's
Yes.
the way. They do it
Oh.
using domain management from the Fabric admin portal. We have a company, right? So let's first of all give company. The company is also called as an organization, right? Company. This is an organization. This could be a limited liability partnership. This could be a private limited company. Organization. This could be an LLP or this could be a private limited organization. Okay. Let's say give it a name Contoso organization. Contoso. Now, Contoso will have their Entra tenant, right? They're going to have their Entra tenant. Contoso.com. Contoso.com. Microsoft Entra tenant. You know what is an Entra tenant, right? Entra ID, in which your employee accounts, employee accounts of this company, devices of this company, right? Security groups of this company, they all will be created under the Entra ID. So let's say you work for Microsoft. So alec at microsoft.com. So your account is created in the Entra ID, right? So that's the Entra ID. This is called as the tenant, right? This is called as the tenant. This is called as the tenant. This is called as the tenant. This is called as tenant. When we say tenant, contoso.com, this is the tenant. Okay. If you do not use, this is what is called as custom domain name. They would have purchased this custom domain name. If you don't purchase a custom domain name, if you don't purchase a custom domain name for your company, Microsoft will give you a domain name. What will be that? Some XYZ xyz.onmicrosoft.com. That is called as default domain name. xyz.onmicrosoft.com. This is called as a default domain name. Domain, this domain is this entra domain, not fabric domain, right? It can confuse you. So I will just rename it, right? Instead of saying it as domain, I can say default custom tenant name, default tenant name. Where do we purchase custom tenant names? We purchase custom tenant names from DNS providers. So if I were to go to godaddy.com, okay, godaddy.com, I can buy a domain. I can buy a tenant name, right? I say I want something like crazyclouds.com for my company, crazyclouds.com, crazyclouds.com. See, crazyclouds.com, someone is already using it. So I can say, give me crazyclouds.in. Okay. So if I get crazyclouds.in, I can use crazyclouds.in as my custom tenant name. Otherwise, Microsoft gonna give me this tenant name on Microsoft.com. If I don't purchase anything, this will be given by Microsoft. This is called as the tenant. Default tenant name is xyz.onmicrosoft.com. If you purchase it from some domain provider, DNS provider, then it will be called as a custom tenant name, let's say contoso.com or crazyclouds.com or xyz.com. One lake is created for this body. If you use Fabric, Microsoft gonna say, okay, you want to use Fabric, okay, so one lake will be created for this entire tenant. For this contoso.com custom tenant name or this xyz.onmicrosoft.com, one lake will be created. One lake for the entire company. Contoso is a company, right? Private limited company. For them, a full one lake is created. Now, once this one lake is created, now in this company, there are various departments. In this company, there is a sales department. In this company, there is an HR department. In this company, there is a marketing department. Okay. In this company, there is an IT department. In this company, there is a XYZ department. Okay. Whatever, etc. Do you want all of them to just create their workspaces like this? Let's say this is created by the sales team, this is created by the sales team, workspaces, sales workspace, marketing workspace, okay, and this is, let us say, some other workspace, IT workspace. They all are created inside the one lake. Or it would be better to organize them. Organization is key to success, right? We would like to organize them. So domain is a logical grouping. It is not a physical grouping. It is just a logical grouping. I can say in the Fabric admin portal, if I am the Fabric administrator, I can say, hey, I want to define logical groups. They are just logical grouping. They are not any kind of a physical grouping, just a logical group. I can say that I want to, inside the one lake, I want to create three logical groups, right? The three logical groups are sales, sales domain, marketing domain, and HR domain. Now, if a analytics project has to be carried out specifically for the sales team, if they are analyzing their Salesforce data, if they're analyzing their CRM data, right? Then they're gonna create a workspace inside the domain. So this is a workspace. Inside the workspace, they're gonna create fabric items, all the fabric items inside, and everything is inside one lake, and one lake is for the entire company, entire organization. These domains are just logical organization, logical grouping. They help us to do logical grouping, not nothing else, nothing more. Logical grouping. When we were school kids, we used to go to the school. We were taught various lessons, various subjects in the school. So we had maths, we had social studies, we had environmental studies, we had physical education, we had various subjects that were taught to us, I could have taken just a single register, a single notebook. But what does the teachers tell us? Keep a separate notebook for separate subject. That will help you to organize your learning, that will help you to do quick revisions of that particular subject when the test will be there. It helps you to better organize your learning. So, in a similar way, domains in Fabric. So, if you look at domains in Fabric, they are nothing but logical organization. They help us to do logical grouping, right? So, facing massive growth in data. So, what is essentially, right? Domains in Fabric, planning domains, key concept, logical grouping. It's a logical grouping of your data relevant to a particular area or a field for which you want to do the analytics, like business department. Okay. It's nothing but just logical grouping. Everything is inside one lake. Everything is inside one lake. Even they are allowing looks like subdomains also. I don't know. You can create subdomains within the domains. I never looked into the Fabric administration in greater detail because as a data engineer, we are not even given the permissions to become the Fabric admin. But this is just a logical grouping. Logical groupings. From the Fabric admin portal, you can create these finance, health, education. And when you now create your workspace, they even allow subdomains, right? They say you can do even subdomains. And then you you put your workspaces under those domains when you do the project, right? Workspace is the organization of items. Group of workspaces are for a particular domain because they may contain workspaces of a particular field or area like sales, marketing. So it is a form of organization, logical grouping to better manage our work, to better manage our federation, to better manage our data mesh, as we call it. You can study, you can think it this way that when we go to school, school is just one place, right? School is just one place, but when we go and study over there, we have different subjects, different fields, different interests. We don't take a single notebook and keep all the data of all the subjects in a single notebook. That would be extremely problematic, right? What we do is that we have a separate notebook for separate subject and we record the data of that particular subject in a separate notebook. That helps us to manage our work, homework, the classwork. That helps us to do revisions more streamlined. That helps us to do revisions. That helps us to prepare for the exam of that particular subject in a better way, right? So specifically, domain is a logical grouping for managerial needs, for management purpose, for data governance, and for data compliances. Really, where we do work is inside a workspace with items. But when workspaces are created, we put them in the domains, which are logical groupings, right? And one lake is created for the entire organization. One lake is not created for a particular workspace. One lake is not created for a particular lake house. One lake is for the entire company. That's why its name is one lake. There is something called as a one lake exploration. One lake. So if you go to the home, you'll find it over here. Not here in the workspace setting. So if you go to the settings of your workspace setting, you will find under the workspace setting one lake exploration tool, one lake file explorer. What will you find in this? All the workspaces of your company. So whichever company you work for, you will find the workspaces of your company under the one lake, single lake for all the Fabric workspaces. All the data, metadata, and all the configuration data will be in a single lake. Mirroring will happen in one lake. Data copies will happen in one lake. Everything happen in one lake. Okay. I will be demonstrating complex semantic model, right? So let's continue. We need to now proceed ahead. All right. So the lab environment is again ready. Let me just log in. Okay. Let me just log in. Use another account. Okay. Each demo environment is only for 1 hour. You have to procure it again if you want to continue your demo. Okay, so here we go. Right. Next. Password. Next. Here we go. Email again. By sign in. Maybe they may ask business phone number. Business phone number. Get started. Perfect. Okay. Done. Back into the lab environment. A fresh lab environment for 1 hour. Okay. So here we go. We are back into a fresh environment for 1 hour. Here we go. Thanks for your patience. Right. So enable the trial. See, I don't have the trial at the moment. So I say, hey, give me the trial, please. Free trial. Activate it in the North Central US. Successfully given the free trial. Got it. And now I have the options of Synapse Analytics. As I just told you, we have Synapse discrete component, which helps us to do Spark clusters. Massive clusters, by the way. Look at this. Look at the size of this cluster, right? Amazing. Similar technology available inside Databricks. Similar technology inside Databricks. I just showed you, right? We can use the state of the art Spark technology right inside Fabric. So, where all team members, irrespective of their roles, are collaborating and synergizing, why would I go to a third party product or to Synapse? If that is an option, I'm happy. That's an option. But if I can do it in Fabric, that would be great, right? So the point is, Fabric gives us the same experience that we have of using the Spark in other technologies. We can use the same Spark with the great capabilities inside the Fabric itself. So, as a Fabric data engineer, our responsibility will be not only to use Spark in Synapse or in Databricks, but also in Fabric. So let us now look at this. I will create a workspace. So I'm going to say, give me a new workspace. New workspace. Fabric class 02 workspace. Make sure it is attached to the trial account and say apply. And now Spark technology is what we are focusing on, right? So now this time, earlier we looked at SQL, structured query language. We even looked at Power Query. We looked it on a single table. We did not make it too complex at the beginning. Later, we're going to have a lot of tables and you're going to create semantic models also on many tables. Some will be facts, some will be dimension tables, right? All of that will come subsequently as you go ahead. Now, inside the Fabric workspace, let me take you to the settings of this workspace. If we right click over here and I click on settings of the workspace, settings, right? You can click from here or from here itself, right? Settings of the workspace, workspace setting. You find right at the bottom, there is something called as data engineering and data science. If you click on that, data engineering and data science, you get your Spark engine setting, setting of your Spark cluster. So if I click on this, you observe that we get the details of our Spark cluster. What we observe is we don't have a need to deploy any Spark cluster because one starter cluster is provided to us. A starter pool of nodes are given to us. Node family, memory optimized, node size medium, number of nodes up to 1 to 10, right? Up to 1 to 10. You can scale it to maximum 16. You can even do dynamic allocation of these executor machines, right? Minimum one would be required, so you can increase beyond one dynamically at runtime, depending on your job scale. Okay. I will highlight these technical settings a little later. Don't overcomplicate your understanding. But you see, memory optimized medium. So what is this? They're saying take this here. So go to Synapse workspace, go over here to Spark, new, memory optimized medium. How many? Minimum one they're saying, maximum 16, I think they're saying. This much. They're giving me this much inside over there at the beginning itself. Starter pool. You see, starter pool. This is the starter pool. Memory optimized, more RAM per CPU, memory ratio to CPU, memory to CPU ratio is higher, memory optimized. Medium. Medium means what? You can see it from here. Medium means 8 vCore and 64 GB of RAM in a single node. Single node. 8 cores, 64 gigabytes of RAM in a single node. So how many nodes we can ask maximum? 16. 16 times 64. You can do a little math, right? So what that would be? 16 times 64 GB. 1024 gigabytes of RAM divided by 1024, 1 terabyte RAM. I am asking Microsoft, give me 1 terabyte of RAM for processing my big data. I'm going to do ETL pipelines. I'm going to do complex ETL processes on large volume of data inside the random access memory. I'm going to be stuffing up to 1 terabyte of data. I cannot obviously use all the RAM, but 1 terabyte of data I'm going to stuff inside the RAM and process it in the RAM. RAM is blazingly fast, 10,000 times faster than the disk. So this is the starter pool. Imagine this is a starter pool. Starter pool. But can I create new pool? Absolutely yes. You can say, I want another Spark pool for my complex ETL pipelines. New pool. Name for the pool, my own pool. Memory optimized, more RAM. Obviously, we want more RAM, right? That's the purpose of Spark. We want more RAM. Node size, small, medium, and large. Other node categories are not available in trial. Okay. If you don't see the other, that does not mean they are not available. They are not available in trial. Extra large, extra large. They are not visible to us. They are available. They are not visible because we are using trial capacity. I cannot deploy this in a trial capacity. Impossible, right? So you can say large up to 8 only in the trial capacity and dynamically allocate these executors, JVMs, executor Java virtual machines at the runtime depending on the job volume. We will discuss these settings a little later when I will be highlighting more technical details to you. So what we used to do inside Synapse, right? We used to deploy these Spark clusters and do complex ETL pipelines. I can do the same thing over there itself in the integrated software as a services, which is Fabric. So you can deploy this, okay? I'm not going to create because unnecessarily there is no need. I already have one pool. So unnecessarily creating another one does not make any sense. But just look at this way, how we can fill it memory optimized, small, medium, large options are there. And then how much maximum do you want? Small, they give up to 32, medium, they give up to 16, large, they give up to 8 under the trial capacity. And what is small, medium, and large? You can clearly observe small, medium, and large is this. Small is 4 vCore, 32 gigs of RAM, quad core, right? I think our laptops nowadays are octa core, 8 core laptops, 16 core laptops. Okay. So this I think is not sufficient in the modern world. Okay. So we would typically go for octa core, 64 gigs, 16 cores, 128 gigs. This would be better. So medium and large would be better. That's why they are giving us medium by default. If you observe, they're giving us medium by default. The starter pool is medium. octa-core at least. Each machine is octa-core with 64 gigs of RAM, and you can have maximum 16 such machines. Imagine 1 terabyte of RAM, right? So each machine having 64 GB of RAM, and you can have maximum 16, so 1 terabyte of RAM. Each machine is having 8 cores, so you can have 8 into 16, which is 128 core. Imagine 128 hyper-threaded cores for your processing in parallel, vector processing and threaded processing in parallel. Amazing, 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 right? So here you see we have our pool, right? You have other options like creating environments. Okay, we're going to be creating the environments a little later. Why? Unnecessary. At the moment, there is no need for me to create any custom environment with custom Spark confs and custom Spark libraries. At an appropriate moment, I will let you know how to create them, how to use them. We will share you challenge exercises where you can practice them. Runtime version 1.3, Spark 3.5, Delta 3.2 engine, right? So from here we can use this. I think is no longer available, right? This will be deprecated. So you have Spark 3.5, Delta 3.2. Okay. And what jobs are running at the moment? Nothing is being running. High concurrency clusters. Jobs of more than one users can run on that cluster. My job, your job, somebody else's job. If we are collaborating in the same workspace, we can use the cluster, and jobs of more than one people can use the same cluster. High concurrency. Again, we're going to come to these settings when we will be highlighting administration. Last module, administration. So when we're going to come to administration, we'll highlight what these technical settings are. But what most important part is that in the workspace setting, there is already a starter pool which is of very nice capacity. 1 terabyte, up to 1 terabyte RAM I can grab from Microsoft. Give me 1 terabyte. Okay. Amazing. Starter pool. Nothing required. Out of the box. Right. Wonderful. So what can we do with it? That's the bigger question. That's the real data engineering. What can I do with it? You tell me. What items can I create with it? So earlier, when you saw that we as a data engineer created a lake house, now we will combine it with a notebook and a Spark job definition as a fabric data engineer. So you as a fabric data engineer will combine your lake house with a notebook and a Spark job definition for running your ETL pipelines on schedule, because we want to automate our pipelines. We want to create efficient and effective pipelines which are properly automated and they are run on schedule, because we want to roam on beaches. We cannot be sitting in the front of a portal and clicking the buttons manually here and there all throughout the day. Gone are those days. Facebook, Oracle, SAP, all of them have already told that 50% of the workforce will be replaced by AI, right? Mid-level software engineers, mid-level data professionals, mid-level data whatever, right? Data professional, they will be replaced by AI. AI would be working instead of them, right? So automation is the key to success, right? So Lakehouse plus the notebook plus the Spark job definition. Sometimes we even need to have custom environments in which our Spark programs are executed. So as simple as it goes, please keep your focus intact. As a fabric data engineer, when we talk about Spark, we take all these four in our purview. We have to now create and manage these four items: Lakehouse, the notebook, environment, and the Spark job definition, right? That is what our focus is as a data engineer. Okay. So now let me demonstrate to you how we can do Spark Analytics in Fabric. So for that, I would have to first create a lakehouse because my source data has to be kept in a lakehouse. So I will create a lakehouse from the data engineering workload. I will give this lakehouse a name, Spark Demo Lake House, and enable lakehouse schema, create. Here we go. So the lakehouse has been created. How do I bring the data inside the lakehouse? How do I ingest the data into the lakehouse? These are the options. Upload files, create a new pipeline, create a new data flow generation to Power Query, enhanced compute engine based data flow, new shortcut or new event stream. As we proceed in the course, we'll be creating all of these things. Yes, absolutely. As we proceed ahead, we have modules that focus on all of these things. But at the moment, again, to keep it simple, this is for simplicity. If I start doing all of this right at the beginning, it may become very complex for people to digest. So subsequently, we're going to be using all of these things as we go ahead, right? At the moment, I will be doing a manual upload. Obviously, under the files, I will do a manual upload of a folder. Upload a folder itself. Okay, I have a folder of orders fact. Orders fact. This is orders fact. I have a fact table dumped as a CSV. It has data of the orders. Two dimensions are there in this. So you see, we created this orders 2019 CSV, 2020 CSV, 2021 CSV, and I would like to load all of them to a delta table. Okay, just to show you the content of this. So I say I want to create a new delta table on top of the dbo dot all sales orders, all orders, you can say. And it is a fact, orders is a fact because it records the interaction between two different dimensions. An order is placed by a customer for a certain product on a certain date. So when I go to Amazon and I search for a particular product and then I buy that product, my transaction is recorded. So that goes into the fact table, orders, that someone placed an order, who placed it, for which product it is placed, and when it is placed are the dimensions, the date dimension, the customer dimension, and the product dimension. We're going to use them later. Okay, don't worry. This is orders fact. I can give it a name, orders fact, right? Fact orders, or you can give it a name, fact orders. Let's give it a name, fact orders, right? File type, all CSV files. I want to upload all the CSV files that I have under this. Okay, load. What happened? Details, headers are missing, it seems. Okay, so you see over here, there are headers are missing in this file. It seems headers are missing in these files. Just give me a second. Let me just verify. Why are the headers missing? Which means the data is for schema at runtime only, schema at query time. Seems headers are being excluded for them. Schema on read has to be done. Yeah, schema on read. There is no column names given here. You see? Now this is not good. I don't know why they have not given a header in this file. This is a sample data that they have given. So this means it is for schema on read. We have to read it in our data frames in Spark and then do schema on read. Exactly what we will do very shortly. I will demonstrate that. So let me try again. If I can skip the headers, new table, CSV, don't use the headers for column names. So it will give C1, C2, C3, C4, something like that. Okay. dbo.fact orders, delta table. Okay. Fact order, the delta table I'm creating for you. I'm skipping the headers. Looks like these files don't have the headers, which means they are purely meant for schema on reading time. So this is all the fact data. I have taken all the fact data because if I want to report on KPIs without drilling them on the dimensions, the fact is sufficient for me at the moment, right? So you see, let me clear the notifications. Now you see that the delta table is also created, the fact order, but it gave unnecessarily the name C1, C2 and all of this, right? Because headers were missing. Okay. So if I were to just look at this table, how does it look like? It looks like this. Can I give the names to these columns? Yes, I can. Very easy, right? How can I give a name to these columns? C0, C1, C2, C3. Is it possible to rename them from here? No, not there. There's no such option to rename them from here, but this is the data. How can I rename them if I were to rename? Yeah, you will have to do schema on read. That is basically once we read it in the Spark cluster. But what we have learned already, whatever we know already from that only. I don't want to load it in a Spark cluster and then do it, right? So anything that comes to our mind, any way that we could name it, yeah, we could go to the SQL Analytics Endpoint. That's what we have learned. SQL Analytics Endpoint, right? So as a data engineer, if someone says, hey, my delta tables are missing the column names because the header was not there. Okay, I can give you a fix for that. Where is your table? Here is a table. Fact order. Select a star from fact order. Let me do a new SQL query. New SQL query. Select. I think there is a query already running, it seems. Yeah. Select star from full table scan. Fact order. Full table scan. Run. Full table scan. Let's see how much time does it take. And obviously C0, C1, all these columns are coming. So how can I give the names to the columns from what I already know? Someone has pasted the PySpark code. That is schema on read code. So you know that I can do something which is called as a visual query. Drag this over here. I can do a visual query. Drag it over here. Something from which we already know. Oh, this is a temporary error, right? Close it again. Try again. New visual query. Yeah, now it works, right? Here it is. So how can I do it? Yeah, okay. So rename from here. So I can now rename them from here, right? If I want to rename, I'm just giving you a solution, right? Just giving a solution. Rename sales order number. Okay. So Power Query people, data analysts can answer such questions, right? That how can I do this? We can do it in Power Query editor, right? Order date. But this will be saved as a view on top of that table, which is fine, right? No problem in that front. Customer name. So if headers were missing, we could fix it in this format, right? We could just simply do it in this way, email, or otherwise someone has given programmatic solution, which is in Spark. That is something which we are learning. So from what we already know, this would be the way to fix it, right? Unit price and then the tax. Fixed. Column names given successfully. And what? Save it as a view in the Lakehouse. Give it a name, fact, order, view. It has the same content as that of the table, only it is renaming the columns, right? And if the underlying data of the fact order changes, the view will automatically reflect those changes. View created successfully. Fact, order, view. New SQL query. Select the top 100. Here it is. So if you want to now do any reports, you can do it on this view instead of this delta table, which was lacking the column names. Fine, we fixed it. But now comes not SQL. Let me close this. This we have already known. I just showed you how to do that, right? Close all of this. Now we want to process this CSV files that we have. Let me go back to the Explorer, Lakehouse Explorer. Here are our CSV files. We now want to process them in PySpark, not in SQL engine. I don't want to do it in SQL engine. I want to do it in a PySpark. technology. If you go to your original data, it can be in any format: CSV, TSV, TXT, JSON, Parquet. It can be in any format. Here we are in our lakehouse, and right over there, there is an option. Oops, where is the option gone? Okay, again, they have it in the SQL Analytics endpoint, right? Sometimes this gets confused, right? So if you see over here, new SQL query, oh, this may be a UI issue then. Sometimes the UI issues happen, right? You may have to excuse me sometimes. UI issues happen sometimes. So go back to the lakehouse, go back to the lakehouse, orders, load to table. No, that's I have already done. Okay, I got it. What it then means is you're going to have to do it from the top. You'll have to select the folder. Earlier, there was an option over here, by the way, right? UI of Fabric has changed 4 times from May 23 to now, right? So this is UI change. Earlier, we had the option here itself. Select the folder and say, I want to open it in a new notebook. We're going to have to select the folder, new notebook. And now this, no, Delta table we have already done, Sri. That's totally straightforward. Load it to the Delta table. We want to load it in Spark, not Delta table. Okay. She's saying go to your lakehouse, go to your orders, or go to your CSV file and then say load to table. That would create Delta table here. That would create Delta table. So new table, sales 2019. No header because header is not there in that CSV file. That would create a Delta table over here under DBO. Sales of 2019. A table just for the sales of 2019. It creates a Delta table just for the sales of 2019. We're talking about loading it to Spark. So select the folder or select the file, okay, and then open it in the notebook. Earlier we had the option here itself, but since the UI has been refined, they have moved it on the top. Okay. The UI of Fabric has undergone 4 major revisions right from May 2023, right? So you say new notebook. Now you see here is our notebook, which I launched for you. Look at this beautiful experience over here, first of all, right? So notebook, let me first change the name of the notebook. Okay. So I'm going to change the name of the notebook and I'm going to give it a name. What name I will give? Sales order data processing. Right now I have just 3 files of only 3 years. And I think I have just few megabytes. You need to ask yourself, you need to believe that I want to do it on terabyte data, on thousands of files. Right now, I just have 3 years data, 2019, 2020, 2021, I think. Only 3 years of data. In a real world, you could have 10 years of data, and each year's data could be in 100 files, CSV files. It could be terabytes of data on which you want to do exploration or analytics or ETL, complex ETL. Sales order data exploration is what I want to do. So what resources are available for me to do all of this? So I have a lakehouse and here is the data. Right now you're going to get that option. Yes, looks like, yeah, you have this and now load data. See, they have moved it at a different location. This is Microsoft's UI changes that they have done. Okay. So if you observe orders, and these are the delta tables. I don't want to load a delta table. Okay. Here, if you load a delta table, it will load something like this. We don't want to load delta table. Okay. We don't want to load delta table. We want to load these CSVs. So see, right click CSV, load it as a Spark, load it in Spark or load it in pandas. Pandas stands for panel data. Okay. We are not talking about pandas over here. Panel data over here. We are talking about Spark. So I say, hey, I want to load that in Spark. So here you see, it automatically writes the code for you. Don't worry about writing the code. And I say, I want to read all the CSV files under the orders folder, star.csv. So all sources, you can explore your sources from here. Sources are visible over here. You can upload the data in the files manually if you wish. Okay, upload here manually if you wish. So you see, what are the resources available? You have uploaded data in files. You can upload manually the data in the files. Lakehouse, which is what we have. You can even do it on warehouse, which we will do subsequently. So here we have the lakehouse. I don't want to do it on delta tables, right? Believe me, we don't want to do it on delta table at the moment. We want to do it on the underlying files of the lakehouse. Okay. So here we have just 3 files. You could have thousands of files over here in various folders, right? So I'm going to say load it to Spark. Replace this with 2019.csv, star.csv, all years data. Let me run it with header true and let's see what happens. Let's run it. It will connect to the standard session. There is also called as a high concurrency session. If you want to run your code on an exclusive session, which means another notebook cannot use that Spark session, the point is that what if there is an error in that notebook? Then your notebook will also error out in the high concurrency session. Right? Jobs of multiple notebooks, job of multiple engineers can error out in the high concurrency session if there is an error in one of the notebook. So if you are doing development and testing, it would be better to do it in a standard session. So that's why you see I connected it to a standard session rather than a high concurrency session. I attached it to the standard session, and now attaching the standard session, here you see it is doing this. When I said header true, the first row of data is taken as the header, which I don't want, obviously, right? So header cannot be true. That's quite clear. So I have to say header false, which Stefan said that you should not have the header true. Otherwise, the first row will be taken as the header itself. So now let's load all the 3 years of data. Spark.read, this is the data frame reader. Spark data frame reader, the Spark session object, Spark data frame reader object, and the Spark data frame reader object has options to read the data, spark.read.load, right? If I were to just show you that, we will be discussing it. The course has been structured in such a way that it is beginner friendly. If I start talking about complex things right at the beginning, you might feel, hey, what is happening here, right? So if you go to Spark documentation, you find it very easily what that is. Spark documentation. We are using Spark 3.5. So API documentations in Python language. And now you find API reference, core classes of Spark structured query language, core classes. And you find Spark session, which creates the object Spark. And then you have Spark dot read dot data frame reader dot load in a particular format. Spark dot read dot load. Give the path of reading, the format of reading, the schema of reading. If your file does not have column names, because we will have to provide this, right? Our CSV files do not have a header. So C0, C1, C2, C3, C4, C5, C6, C7, C8. So that is called as a schema on reading because our CSV file does not have headers. So we're going to have to do schema on reading. So let's do schema on reading. Let me write a little markdown and say schema on reading, right? Bold. This is markdown to explain what I will now do. Schema on read. So I'm now going to do schema on read, but you might ask how to do it. See, obviously, how will I do schema on read? You can see over here, it says you are reading something, you are loading something, you need to give me the schema. So how to create the schema? PySpark.sql.types.struct type. Don't worry about this, what this is. Don't worry about this. Don't worry about what this is at the moment, but you can see I'm connecting the dots. Column names are missing, so we will have to give the schema, right? Column names and data type is called as a schema in technical definition. What is schema? Technical name schema stands for column names and the data type of the column. So you give a name to this column and what will be the data type of this column? What do you think? What should we give as a data type over here? I think string is required because this is S0 and something something. This could be an integer. This could be date, time. This could be again string, number like integer. This could be floating point. And what column names you wish to give. That's called a schema, right? Column names and data type. So you're gonna have to provide that because your CSV file does not have it. Okay, your CSV file does not have. So you're gonna have to provide the schema. So they are telling you how you have to create pyspark.sql.types. You have to create it using struct type in this way. You're gonna have to create it in a struct type with struct fields. Okay, struct type with struct fields, and then use these data types. So how to do that? Let me grab it for you. Schema on read. Here it is. You can feel the code, right? You can don't worry about it. I will be explaining it in more detail, right? You need not worry at the front what is happening. But can you connect the dots from pyspark.sql.types? Why? Because they are telling you that if you want to define a schema, you have to use pyspark.sql.types and specifically the struct type out of it. So I'm importing this pyspark.sql.types. You see, I say pyspark.sql.types. And what did they say? How do you have to define the schema? You have to define the schema using struct type, using this object, struct type. And struct type is made out of struct fields. So you see, I'm making it out of struct fields. So my schema is a struct type made out of struct fields. How many struct fields? Equal to the number of columns. 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. So how many columns? Total 9, 0 to 8, 9 columns. So one struct field for each column, and then I have to tell column name and data type. So I say these will be the column name and this will be the data type of that column. So for the first column, I'm giving string. For the second column, I'm giving integer and so on and so forth. As I just highlighted, you can see date, string, integer, float. Simple. Right now, do not worry about what we are doing in case you are feeling, hey, what is this happening? Right? Don't worry on this front at the moment. What is happening? It's simple. We are reading, header is missing. We are loading all our files from the Lakehouse. Headers are missing. So we have to do schema on reading. And you can clearly observe how to do schema on reading is pyspark.sql.types with a struct type and struct fields. And then these data types. And exactly that is what I did. I created a struct type object, order schema, 9 struct fields for each column. And then I said, hey, this is the column name that I wish to give. And this is the data type that I want for that column. And now when you read my CSV files, please also read it with the schema. So I am now saying schema. Okay. I am now providing them the schema. Okay. df.read spark.read.load from the particular schema. So now it will define this schema and read my data CSV with this data type and these data types and these column names. Now I have proper column names and proper data types. I can verify it by saying df.print schema. I can ask it print df.print schema. See, it tells me that you have a data frame with these column names and these data types. Wonderful. You have these column names with these data types over here.
Thank you for watching this video. Now, all you need to do is click the link in the description below, or if you're just starting out, type k21academy.com/dp700 into your browser. Once you're on the page, enter your name, email ID, and your phone number. Then click on register now. Now, here you will be redirected to a thank you page where you can easily add the session to your Google or Apple Calendar. This is your chance to gain valuable insights, so don't miss out. Click the link now and take your learning to the next level. See you in the session.